Hi, good morning. Uh, Before the start of the video, I just want to thank every guy for subscribing my videos, and I hope you guys enjoy my latest study music. And today we're going to do some DP solutions, and let's start. So suppose right now you are, imagine yourself as a skis manager in the skis company, and your boss gives you a task that is to distribute different skis to a different skiers based on their heights. And our goal is to find the minimum disparity between the skis and the skiers. So by that I mean is, this is the height of the skis that you can distribute it. And this is the height of different skiers. And I want you to find a solution that can find the minimum difference between those heights and add it up. And I want the minimum number of this. So right now I want you to pause the video and think of your own for like 5 minutes. After you think of 5 minutes, come back and see my video. Okay, let's start it. Great! I hope you solved the video, the questions. So right now I'm going to walk through my solutions for you guys, and let's see what is going on here. So before we solve this solution, we have two observations. This is super significant. The first observation is the way you distribute it like this is no less than the way you distribute like this. So suppose like this is the optimal solution. This way of distributed thing is also an optimal solution, since it is less or equal to this one. And the observation 2 is based on observation 1. So suppose we have n pairs of shoes with n pairs of skiers, and this can result in this graph here. And from observation 1, we know that this way of distributing also is an optimal solution. So we can lead to that we can just distribute this, and this is also an optimal solution. And this leads to this function here. And then here comes my recursive version of solution. So I'm going to divide my function as pure skis and with two input. The first one is the skiers, which is 0 to n people, and the skis is 0 to n people, because we have n pairs of shoes with n people. And we first look at the base cases. If I have people more than shoes, then this is an invalid situation. So we return the infinity. But if we have n equals to n, then we can use the observation 2 that we just discovered here to just pass the skiers and skis to this function. And here comes the important part about our DP solution. The DP is actually just use it or lose it. So there are just like two scenarios: whether the skiers pick the shoes, so then we just have n minus 1 because the people already got the shoes, or n minus 1 because the shoes will already be distributed to that people. And we also have to add the disparity between the two, and this is the usage scenario. And the loser scenario is the people still didn't pick the shoes, but the shoes we don't want it, so we just lose it. So we use the n minus 1. And in the end, we want to find the minimum between the use it or lose it and return back it. So how does the DP table looks like? So I will just draw the DP picture for you. So let's just make the above example like to make our DP table. So for our DP table, we have to like look like this. So this is your individual weight like this, and this is the skis weight, skis height. Sorry for that. And okay. Okay, let's see. what's going on. So let's just fill out the base case first. So when and the n here is, this is just the way, this is actually not our how a DB table looks like. The real DB table looks like this. This is 0, 1, 2, 0, 1, 2, 3. But I put the high scales to make the idea more clearly. So let's see the base case. When n bigger than n, then we have to fill in infinity. So let's see where does n bigger than n. So this one n bigger than n, so infinity, and this one infinity. This one here is infinity. And okay, this one is the same, so we don't have infinity. And this one n is bigger than n, so we don't have infinity here. And let's fill up the cases where n equals to n. So here, if n equals to n equals 0, 0, so it's like 1. And in this case, 1, 1. It's 1 plus the original 1, so it's like 2. And this one here, like 12 plus 2, it's 14, I guess. Okay, so we fill our base case. Now we have to focus on filling the DP table. So your solution is either use it or lose it. So we start from here. The use it is, use it, you got your result from here. Sorry, got the wrong one. We start from here. Here's our O0. This is just some ordinary situation, so we just fill in 0. So yeah, we start from here. So you either use it or lose it. So when you use it, you got your result from here, and plus the disparity, or you lose it, you got your result from here. And in this case, the minimum is 0, so 0 plus 0, so we got the result from that is still 0. And we got another result from here, like continue to fill in, we finish this line, and here is also use it or lose it, or use it or lose it, so it's still 0. And here, use it or, oh sorry, here's not 0. Here we lose it because 51 minus 50 is 1, and 0 here, so it's 0. And use it or lose it, like here it's 2, and here it's 0, so we continue filling 0. And here, let's see, use it or lose it. Use it is 2, lose it is 0, so we got 0 here. Use it or lose it, like 0, use it is 0, lose it is 1, use it is 0, so we got 0 here. And here is either use it or lose it. Use it is 12, and lose it is 0, so I got is 12. So yeah, we got our result here. Anyway, happy holiday. Bye guys.